Hi everyone, this is my embedded controller project that I've been working on. It's a 4-layer PLC style board designed with full isolation on all the I/O. For this demo, I've set up a basic plant irrigation system using soil moisture monitoring for pump control, but the logic is handled entirely over Modbus with no hard coding required. Starting with the reservoir, I've got a float switch on a digital input and an LED on an output to signal when it's empty. I'm using the local web panel to map these rules, one to turn the light on when the float drops, and one to turn it off otherwise. As soon as I send that over Modbus, it's live and stored in the EEPROM. You can see when I fill the reservoir and the float rises, the LED turns off. One thing to note here, all the field I/O is running off an isolated supply, kept completely separate from the controller's logic. For the soil moisture sensing, I'm using a secondary PCB module I designed to convert the sensor's 0 to 3.3 volt signal into a 4 to 20 mA current loop. That current goes into one of the analog inputs, which I've toggled to current mode. The board supports both voltage and current on all analog input and output channels. I've also mapped a copy rule to mirror that input current as a voltage output to this voltmeter, which acts as a moisture gauge. Now for the actual automation. I've set a rule to ensure the pump stays off when the moisture is above the 12-bit value of 30,000 or if the reservoir is empty. To water the plants, another rule turns on the pump when it drops below this threshold, provided the reservoir isn't empty. When I send this final rule over Modbus, the pump kicks in, watering until the moisture exceeds the threshold. If I manually pull out the sensor to simulate dry soil, but let the reservoir drain below the float switch, the pump kills immediately. The empty signal acts as a physical interlock. Obviously, you could do this with an Arduino very easily, but the point of this project was to handle industrial level requirements. The board handles 24 volts digital I/O, extra low voltage rated relays, and configurable analog I/O. The MCU is an STM32 powered by an onboard buck converter for efficiency, with a linear regulator downstream to keep the MCU supply clean. Everything, including automation rules and configuration, is stored on the onboard EEPROM. I've also integrated SD card logging, an OLED for diagnostics, and protection for transients, reverse polarity, and overcurrent. It's all open source, so the datasheet and the GitHub repository, which includes the Altium project, STM32 Cube IDE code, and the web panel, are all available on my website.